Alright guys, so in this video I'm going to go over test 3. So test 3 is going to be entirely on slope-intercept form, right? So slope-intercept form, well, let's do this. I'm going to go to a blank page real quick, talk about a few things about slope-intercept form. So, spelling at least, slope-intercept form, and then you can put, of a linear equation, because that's what we're talking about. We're talking about linear equations, meaning lines, okay? So, and slope-intercept form is y equals mx plus b. Now, let me talk about your terms real quick, and your variables. So, b is the y-intercept. So, for example, if I have like some graph, I need maybe a darker marker, maybe. Let's see. Alright, so if I have a graph, okay, and I have a line crossing that graph, okay, at some angle, where it hits the y-axis, that's known as my y-intercept, and we use b to denote that. So in this case, so say maybe this is 1 too high, so then b would equal 2. Of course, every point on this graph, so if this point is at, for example, if this point is at 0, 2, then every point has an x and y coordinate. So that would be like your x and your y on this specific point. It's 0, 2, your x, so left and right, 0. Your up and down is 2, so that's your x, that's your y. Then this m right here is another very important component, and that's your slope. So in this case, my slope would be negative. I'd be going down some amount and over some amount. Down some amount and over some amount. So remember, your slope is always rise over run, and that's how it should be expressed. So with that being said, I'm going to go ahead and jump straight into this. There's a little bit of vocabulary for you. Another recommendation is if you're watching this video, I would fast forward to any section that you need help on. If you watch the entire video, hopefully you can understand all the concepts on this test, because it's actually pretty simple. Everything is based on slope-intercept form. So it says write an equation of a line in slope-intercept form. Now, I might not tell you in slope-intercept form on the test. I might just say write an equation of a line. But the point is, if you are given, so let's say it this way. If you're going to write the equation of a line in slope-intercept form, you need a slope and you need an intercept. So I'm going to write that up here because I'm going to continue referencing that. A slope and an intercept. Now that might be tough to see. I'm going to walk around to the other side of this just to make sure you guys can see it on your screen. Barely. Let me write it over here, and I'll write it in a different color. You need a slope and when I say intercept, I mean y-intercept. You need both of those in order to effectively write an equation in slope-intercept form. So, in this first case, it just says write an equation, and you're given the slope and the intercept. So there's nothing that we have to find. Can I write an equation? Yeah, I have a slope. My slope on number 1 is 5. Yes, I have a y-intercept. My y-intercept is -3, and I need both of those components to actually write my equation in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. And just a second ago when I was defining this stuff, your y-intercept is your b, okay, and your slope is your m, always. Slope is always the m. Notice it's always attached to the x. Again, if you can't see that, I realize there's some kind of reflection there, so let me write it over here. Y equals mx plus b. So m is always your slope, b is always your y-intercept. So when I write this out, I'm going to have y equals m, which is 5, times x plus b. So plus, it doesn't always have to be plus. So in this case, it's a -3. So if I added -3, that's the same as -3. Okay, or if on the test you write something like plus -3, that's also true. It's kind of silly because when you add a -3, it ends up just being minus. Okay, so y equals 5x minus 3. Let me go ahead and do a few more of these examples. Y equals 3x plus 2. That's number 5. And again, if you can't see this on the video, then what you have to do is just download the worksheet online from the same page that you got this video from. Okay, number 4 is y equals slope is 7, so 7x plus 1. Number 6, y equals slope is negative 4, so negative 4x, y-intercept is negative 9, minus 9. And that's it. So if you're going to write an equation in slope-intercept form, you're given the slope and the intercept, then all you have to do is write it. It's going to get more complicated in a second. So that's the first type of example. All right, second type of example is they don't just so clearly give you a slope and an intercept. They give you a graph. It says write the equation in slope-intercept form of the given graph. Okay, so you have graphs in this one. So 9, 10, and 11, numbers 9, 10, and 11. So you need to find, if you're going to write an equation, it stands true still that you need a slope and a y-intercept. So when you look at the graph, the y-intercepts are really easy to see typically. So we have y-intercept, let's say we're doing 9. My y-intercept is right here. Remember at the beginning of the video I defined the y-intercept where the line is crossing the y-axis. And you can see right here b equals negative 3. So my y-intercept's at negative 3. And remember I use b to represent y-intercepts. Okay, my slope, the way you calculate slope is when you look at this line and you look at the grids in the background, what you're looking for is where that line perfectly crosses through an intersection on the grid. So not if you look right here at negative 3 and you're kind of tracing this line up and to the right, it's not this one, but look at the next one right here at this point. At 1, negative 1, it hits solidly on the intersection of a grid. Okay, at 2, 1 hits solidly at the intersection of a grid. At 3, 3, it hits solidly at the intersection of a grid. Okay, so what you're looking for are those solid intersection points, because all you have to do now is to calculate the slope, you count. How did I get from one solid intersection point, from one point to the other? So from here, I went up 1, 2, and then I went right 1. So remember, at the beginning of the video, I referenced slope as being rise over run. So my rise is, I went up 2. So the rise is talking about how much you went up, or if it was negative, it would be down. And then my run is how far I went right, and if it was negative, it would be left. So run is left and right, rise is up and down. So I went up 2, that's the rise. I ran 1. So notice, any point to any other point, it's the same thing. So from here to there, up 2, right 1. Even if you were going left or right to left. Now typically we read graphs from left to right, but if you're going right to left, you went left 1, so you would have gone and down 2. So you would have risen negative 2, you would have went down 2, like 1, 2, and then left 1. So negative 2 divided by negative 1 is the same thing as 2 over 1. Okay, a negative divided by negative is the same thing as a positive. Making sure I'm still recording. Okay, everything is good. So anyway, I just explained multiple things, and if you guys go back, pause the video, think about what I'm saying. I'm trying to be articulate. Hopefully I'm not messing up with my words. But now we have a slope because we calculated, or we counted between how we got from one point to another. We have a slope, which is 2, or 2 over 1, and we have an intercept, which is negative 3. So I can write my equation now in y equals m, which is 2 over 1, x plus 3. And if you wanted to write your m as just 2, because 2 divided by 1 is 2, you can do that. I'm going to go ahead and do another one real quick. So right here, on number 10, I'm looking for solid intersection points. So here's one. They gave that one to you. There's another one right in between the 2 points they gave to you. And here's a third one. Notice they're all solid intersection points on the grid. So how do I get from one to another? I count, well, first let's talk about the y-intercept. That's where it's crossing the y-axis. So my y-intercept is at positive 2. Okay, my slope, I go down 1, 2, 3 over 1. So I went down 3 over 1. Let's just make sure. It should work from this point to the next also. I went down 1, 2, 3, and I went right 1. Yeah, so down 3, right 1. So there's my intercept, there's my slope. I can write it in y equals m x plus b. So again, referencing my slope-intercept form, it's y equals mx plus b, where m is your slope. Notice I've just put the slope here. And then b is my y-intercept. Notice I just put the y-intercept there. All right, moving on. Graph each equation. This is where some people struggle. It shouldn't be a struggle. So now we're not writing an equation. So I'm going to put this aside for now. It's graphing an equation. We still need a slope and an intercept. But here's the most important thing about graphing an equation. You have to solve for y. So in number 12, you can see it's y equals x plus 4. Number 13 is y equals negative 2x minus 1. These are both ready to graph because I've solved for y. Number 14, it's x plus y equals negative 3. This one's not ready to graph. I need to solve for y first. So in order to solve for y, I want to isolate this positive y, so I need to get rid of that x right here. Now that's a positive x also. So to get rid of a positive x, I'm going to subtract x. And what you do to one side, you have to do to the other side. So my x's cancel. So I have a positive y on the left now, equals equals negative x minus 3. And you got to keep these things separate because they're not like terms. Okay? So y equals negative x minus 3. Now I can graph number 14. So I've solved for y on number 14. I'm going to erase this and write it over here. Okay, y equals negative x. Okay, now I can graph 14. So here's how you graph. Graphing, and if you want to take notes, take notes. First thing you need to do is solve for y. Second thing, once you've solved for y, start with your y-intercept. Okay, so my y-intercept on number 12 is 4. So 1, 2, 3, 4. You start at the y-intercept, so put a dot at 4 on your y-axis. On this one, I'm going to start with my y-intercept, but I'm going to put my dot at negative 1 because my y-intercept's at negative 1. This one I'm starting with my y-intercept, and that's at negative 3, so I'm going to put a dot at negative 3. So you always start at your y-intercept. And then from there, you use your slope. Remember, it's attached to the x to draw the rest of the line. So right here I have, these slopes are kind of tricky, and they always trick people, but they're the easiest actually. They're so tricky because you don't see them. But it's the number in front of this x. How many x's are there? There's one x. So you can just put a 1 there. We typically in math don't do that because there obviously is just one x. Okay? But if there's not a number in front, it's a 1. And then also, 1 divided by 1 is still just 1. But the reason I put a numerator and a denominator there is because, again, slope is always dealing with rise on top and run on bottom. So if I just have a variable by itself, then you have a rise of 1. So from this dot now, your y-intercept, you rise 1, and then you run 1. You rise 1, you run 1. And you just keep doing that over and over. And what you notice is there's going to be a line. Okay? And you're going to connect those dots on that line. So this one right here, negative 2. Again, negative 2 divided by 1 is still negative 2. I didn't change anything. All right? But I just made it to where I can see a rise, which is negative 2, and a run, which is 1. All right? So I start at negative 1. I rise negative 2. So down 2, I run 1. Down 2, I run 1. And notice you're going to be making a line again. And pretty much you want to just do that enough to where you can make a straight line. Now, truly it should only take 2 points to make a straight line, but sometimes it's nice to use more. This one starts at negative 3. I'm going to go down so that it's a negative, but there's still negative 1 divided by 1. Okay? So negative 1, down 1, right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. You just keep doing that, and look, straight line. So that's how you do all three of those, actually. Okay, going on to the next page. You guys, if you don't understand something, all you have to do is type into YouTube graphing in slope-intercept form, and you'll get a million videos. That's probably an exaggeration, but I would say truly probably thousands of videos of people teaching the same thing. Okay, write an equation of the line that passes through the given point with the given slope. Now this is where it gets a little bit more complicated. So remember, we're writing an equation. We want that equation in slope-intercept form, always. This whole test is going to be about slope-intercept. So we have a slope, we have an intercept. To write an equation in slope-intercept form, we need a slope and an intercept. So if you look at all these examples, numbers 1 through 9 on the back side of this page, they all have a slope and a point. So you have a slope. You have a slope of 1. You have a slope of 2. You have a slope of 4. Slope of -2. Slope of 3. All of them have a slope. So we have the slope part covered. We need the y-intercept to actually be able to write this equation. I'm going to make sure we're still recording. Yep. Okay, so we need the y-intercept. This is how you find the y-intercept. You use the information given to you. So for example, if I'm doing number 4, here's my slope. That's my m. So m equals 4. Here's a point, just a random point. But what you need to realize is a point also is an x and a y. So we have an x, we have a y, and we have a point. Or I'm sorry, we have an x, a y, and a slope, and an m. So if I take those and I plug them into my y equals mx plus b format, so in other words, I'm plugging them into y equals mx plus b. And I realize I'm writing over the top of this, but realize I'm also doing number 4. I'm not doing 5. All right, so y equals mx plus b. So y is 9, and I'm getting that from this point. M is 4. I'm getting that from the slope. X is 1. I'm getting that from the point. And notice it's the slope times x, so it's 4 times 1. And then b is my y-intercept, and I don't have that, but it's actually what I need to solve for. That's what I'm solving for. That's the whole reason I'm doing this, is so I can solve for b. So now as I continue to solve this, I have 9 equals 4 times 1 is 4 plus b. And if I want to get b by itself and solve for it, I want to isolate it, I have to find a way to get rid of that positive 4. So I'm going to subtract 4. 4 minus 4 is 0. So I have b by itself on the right side. That's what I want. 9 minus 4 is 5. b equals 5. So now I have my slope given to me right here. Check. I have my y-intercepts that I just solved for. Check. I have all the information I need to write an equation in slope-intercept form. So my answer is y equals m x plus b. Here's the equation that has slope of 4 and passes through the point 1, 9. And again, I want to reiterate, if you guys can't see this or you're having trouble seeing it, I understand this is my best way of recording, so that's why I put the worksheet right next to this video, all right? At least on Schoology. Okay, next example. And I guess not the last example I'm going to do, but probably I would think the toughest. So in numbers 10 through 18 on this review, you are asked to write the equation again of the line that, but this time that passes through 2 points. Okay, so it needs to pass through, let's say I'm doing number 17. My line needs to pass through 3, 3, and 1, -3. So if I'm going to write the equation in slope-intercept form, I need a slope and an intercept again. In this case, I don't have either slope or intercept, so I've got to find both. I suggest starting off finding the slope. All right, so here's how you find the slope. Slope is y2 minus y1 over x2 minus x1. Now, this might seem confusing to you or a lot to remember, but it's really not. Think about slope. What you already know about slope is that slope is rise over run. So it should make sense that the y's are on top. That's my rise. The y variable is how much I go up or down on a graph. My run variable, x, is on bottom. Okay, so it's a rise over run. That's what that is, actually. So to find my slope, y2 minus y1 over x2 minus x1. So I'm going to use both of these points. Now, if you can't see these points, I'm going to rewrite them here. Oops. 3, 3. And again, they're on your paper. And 1, -3. And I'm going to label these points. Let's say this is point 1 and point 2. Or point 1 and point 2. It doesn't matter which is which. Just to mix things up, I'm going to call this one point 1. So if this is point 1, that's x1. This is y1. This is going to be x2 and y2. So plugging it into this slope format, I have y2 minus y1 minus, now look at this, minus y1 is -3. So y2 minus y1. So it's 3 minus -3. So you have to have both those negatives and realize that's going to be positive in a second. Divided by x2 minus x1. So 3 minus negative 3 is positive 6 over 3 minus 1 is 2. So my slope, my m is 3. So now look at this. I've got my slope covered. So I need to write this equation out. The next thing I need to solve for, and I'm going to use that slope to actually solve for it. I need to solve for my Y-intercept. Okay. So I've got my slope. That's what I used the whole y1, y2, x1, x2 thing for. All right? Got my slope. Now that I have my slope, I'm going to take one of these points, and it doesn't matter which point, again. So I'm going to use this point on the right. I'm going to take the x and the y from this point. So every point it has an x and a y. So I have an x, a y, and I have an m. And I'm going to do actually what I did in the last example, and I'm going to plug x, y, and m into my equation, my slope-intercept form. So again, that's y equals mx plus b. I'm going to take my x, my y, and my m, so I can solve for my y-intercept, my b. So y is negative 3. Negative 3 equals m is 3. X right here, the x is going to be 1. So again, it's 3 times 1 plus b. So I have negative 3 equals 3 plus b. So I'm going to subtract 3 from both sides so I can solve for b. And when I do that, I end up getting negative 6 equals 3 minus 3 cancels, so b. So check that out. Look, I've got, and you guys might not be able to see it very well, but you need to listen to my voice sometimes too. If you can't see what I'm doing, at least listen to what I'm doing. All right, and I'm sure you can figure it out. So b equals negative 6. So my y-intercept is negative 6. My slope is 3. So I've got my slope and my y-intercept. I can write my final equation. Remember, in y equals mx plus b form. So here it is. Y equals m x plus b. And again, my whole goal is to write the final equation. So it has that y and that x in it. I just need the m and the b. That's what I'm looking for, my slope and my y-intercepts. All right. Last example that I'm going to go through, I'm going to be talking about perpendicular and parallel lines. Now, I realize at the bottom of this, there are some examples that I can work through. Well, shoot, why not? Let's just work through these examples. Now, what it says here is parallel. I'm going to change this up. Sometimes I'm going to do a parallel one, sometimes I'm going to do perpendicular. All right. Nope, I changed my mind one more time. I'm going to go ahead and just make some equations up. So I want to find an equation. I'm going to write an equation. So the instructions might say something like, write an equation of a line that is perpendicular to the given equation. So here's an equation that I'm going to give to us. Let's say it's 2 over 3x plus 4. So perpendicular to that equation and passes through some point. Let's say 2 comma 5 and passes through that point. How do I write an equation that's going to be perpendicular to this equation and passes through this point? So remember, what it means to be perpendicular are two lines that are crossing each other but at 90 degrees. So they're completely opposite, okay? At least regarding the slopes. So when I'm talking about perpendicular and parallel lines, we took notes on this in class about a perpendicular line. To find the slope of the perpendicular line to this one, you take this given equation's slope and you do the opposite slope. You need the opposite slope. So the line we're going to need, the slope we need for the line we're going to create is going to have the opposite slope of this. So instead of 2 over 3, it's going to be 3 over 2. Instead of positive, it's going to be negative. All right? And that's how you make a perpendicular slope. So if we're going to make a line, I'm sorry, one more time, just because I realized I messed up a lot of my words in the last time. So if we're going to make a line that's perpendicular to a given equation, notice what's going to make it perpendicular are the slopes. So if this equation has that slope, then I need to make an equation with that slope. So it'll be perpendicular. All right? Honestly, this plus 4 doesn't even matter if I want it to be perpendicular. All that matters is the slopes. Now it's perpendicular, and I need it to pass through this point. I also need it to pass through this point, 2, 5. So here's the two pieces of information I need. Here's an x and a y. Okay, so I have, I'm going to use y equals mx plus b. So again, to write an equation, I need a slope. Check. Got it. I need an intercept, though. That's what I'm doing right now. I'm going to solve for this intercept. So y equals m x and then plus b. Now again, that b right there is, I need that b so I can actually write my equation in slope-intercept form. So let me just write this to the side. So I've got my slope. I need my intercept. That's what that's for. All right. 5 equals negative 3 over 2 times 2. It's going to end up just being negative 3. And if you need a calculator to do that, then use a calculator. That's fine. So to solve for b, that's a negative 3 on this side. So I'm going to add 3 to both sides. So 8 equals b. Now I have my intercept. I have my slope. I can write my final version of the equation, which is going to be y equals mx plus b. mx plus b. There it is. So notice we're doing very similar things. Each type of problem we're doing, it's very, very similar. It's all dealing with y equals mx plus b. Most of the time it deals with taking a point and a slope and plugging it into that so I can solve for my intercepts. Very, very similar things. All right. I'm going to work one example real quick of a parallel line, and then I'm going to be done. All right. So if I'm asked to find a line that is parallel to a given equation, so here's my given equation. I'm going to make one up again. Let's say it's negative 3 over 4x minus 2. If I want to find a line that's parallel to this and passes through the point, let's say 3, 8. So if it's going to be parallel to that, that means, so if you think about parallel lines real quick, parallel lines never touch each other. And they're always going in the same direction. They're perfectly straight, never touch each other. So if they're parallel, that means the slope, look at the slopes of both of those lines. They're the same. The slope needs to be the same. So perpendicular, the slope needs to be, the slope needs to be opposite. Parallel, the slope needs to be the exact same. Okay, so my new line that I need to create, if I need to write an equation of a line that's perpendicular to this line and passes through that point, then my slope needs to be this. I think I just said perpendicular, but I meant parallel. Parallel to this line. So the slope needs to be the same, and it needs to pass through this point. So again, now it's just like the other one. If you think back to the last one, all we did to find a perpendicular line, we changed the slope. So it would have been positive 4 over 3. But in this case, we want a parallel slope, so we want it to be the same. In the last equation, we use this x and that y, and that m to plug into y equals mx plus b, so we could solve for our intercepts. We need the intercept because we already have the slope. We have the slope, we need the intercept. All right, here's a y equals m x plus b. Unfortunately, this is going to be kind of hard to do in my head. Well, I guess maybe not too bad. All right, so I have 8 equals, if you take your calculator and multiply this out, you're going to get 9 over 4, which is 2.25. Yeah, so it's going to be negative 2.25 plus b. And the way I get rid of negative 2.25 is I add 2.25 to both sides. Remember, what you do to one side, you have to do the other side. All right, so these cancel, which is what I wanted, and I get b equals 10.25. Now, as weird as that looks, and with the decimals, it's still just a number. So my intercept is 10.25. Got my intercept, check. My slope is negative 3/4. Got my slope, check. I can write my final version. Y equals negative 3/4 x plus 10.25. And guys, if you graph this, what you would see is that it really is parallel to this. So look, the slopes are the same. It's going to be parallel, and it's going to pass through this point, 3, 8. All right, I'm glad I actually finished this. It's a long video, but what you need to realize is just fast forward to the portions that you need to study and I hope you do well on the test. I'll see you guys in a little while.